Hello everyone, welcome to the course Data Structures. This is N. Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Today we'll be discussing about binary search tree and its operations. Here we'll be knowing about what is binary search tree and binary search tree construction and what are the different operations under this binary search tree or insertion, deletion and search. All these three operations we are going to see now. Yes. What is the difference you are going to find with the binary tree and binary search tree? Binary tree is nothing but a node consists of at most two children. That means a node consists of at most two children. That is nothing but you may have 0 children or 1 or 2. Any of these cases can be satisfied with the binary tree. But in binary search tree, it is different. Let us see what is the definition of a binary search tree. Binary search tree is a special kind of binary tree in which nodes are arranged in a specific order. It is also a binary tree, but it follows some specific order in storing the nodes. What is the order it is going to follow? In binary search trees, each node contains these two conditions. One is only smaller values in its left subtree and only larger values in right subtree. Right? All the smaller values are going to be stored in the left subtree and all largest values are going to be stored in the right subtree based on the root. You could observe 25. If you could observe all the nodes 20, 10, 5, 12, 22, all these nodes elements are lesser than the root node. And on the right subtree, if you can see above 25, after about 25, 36, 30, 28, 38, 40, 40. All these are on the right hand side. Now, if you have given some elements, how to construct a binary search tree according to this. Let us see step by step. These are the elements that was given. When you are going to construct a binary search tree, we have to follow the same condition. Root node should be, whatever the element you have given, allow the first element as a root node. Whatever the element that was there in the order, that element should be the root node. Consider the given elements and insert them in the BST one by one. One after the another, we need to insert the elements into the BST. Okay. The binary search tree will be constructed as explained below. First, I am going to have the first node is 50. 50 is going to be inserted because that is the first element that becomes the root node. Next, we have the element 70. Okay, 70 has to be inserted. Now, we need to check with the root node. 70 is greater than 50. So, we need to insert it on the right of 50. Yes, 50 right we have inserted. Then, insert the 60. 60 is greater than 50. Right of 50 we need to go and we need to compare this element with the node which we have already there. That is 60 is less than 70. That's why we need to insert it on the right side of the tree. Then insert 20. Now compare with the root node. 20 is less than 50. That's why we need to insert it on the left side of the root node. Next, insert 90. 90 is greater than 50. That's why we need to go to the right hand side. Then from there you need to check with 70. 90 is greater than 70. So that we need to insert it on the right side of 70. Then insert 10. Compare with the root node first. 10 is less than 50. So, go to the left side. 10 is less than 20. Go to the left part of it. Next, insert 40. Yes, 40 is less than 50. Go to the left. 40 is greater than 20. So, that we need to insert it on the right of it. Insert 100. 100 is greater than 50. Go to the right of it. 100 is greater than 70. Go to right of it. Next, 100 is greater than 90, go to right of it and we are going to insert the element there. Right? Like that way, we are going to perform or construct a binary search tree based on the given elements. Now, commonly performing operations on binary search trees. What are the different operations we are going to perform on binary search trees? Those are search operation, insertion operation and deletion operation. These three operations where we are going to perform in binary search trees. First, we'll see into the search operation. Search is nothing but search operation is to perform a search, a particular element in the binary search tree. Whether a particular element or node is present in the binary search tree or not, we need to verify, right? What are the rules we need to follow? Compare the key element with the root node. If the key element is at the root node, then return the root node. If the key element is greater than the root node, then recursively check with the root nodes in the right subtree. If not, we are going to check the element in the left subtree. That is, if key element is smaller than the root node, then recursively call the root node's left subtree. Okay, this is the procedure where we are going to follow. Now check. Consider the key element 45 to be searched in the given BST or not. What is the procedure we need to follow? First, we need to check with the root node. Is key value is 45? No. Now we need to check key value is greater than the root node or less than the root node. Key value is greater than the root node. That is 45 is greater than 25. That means we need to go for the right subtree. Again, check with the root node. 45 is less than 50. That's why we need to go for the left subtree. Yes. 45. Again, check with the root node. 45 is greater than 35. Need to check for the right subtree. Right. But here you have 44. 44, that is 45 is greater than 44. But we don't find that node in the list. So we can say 45 is not present in the above BST. Like this way we are going to perform the search. Then coming to the insertion. Insertion already we have seen one example. In the same way we are going to perform the insertion also. Insertion is performed to insert an element into the binary search tree. Here what is the rules we are going to follow when you are going to perform the insertion. The insertion of a new key always takes a part of the child of some leaf node. For finding out the suitable location for that leaf node, what we need to do? Search the key to be inserted from the root till some leaf node is reached. Once a leaf node is reached, insert the key as the child of that leaf node, right? Based on the same conditions how we have verified in the searching, in the same way, we need to insert the key element as a leaf node. How to be inserted, right? Here you can see this is already given tree. Into that I want to insert the element 40. How to insert it? First I need to check with the root node for 100. 40 is less than 100. So I need to go for the left subtree. And in this left subtree, I am going to check 40. 40 is greater than 20. Go to the right subtree. Again check with 40 is less than 30. Sorry, 40 is greater than 30. So I need to insert 40 as the right subtree for 30. Okay. Like this way we are going to perform the insertion. Whatever the elements you are going to get, follow the same procedure. Next, binary search tree deletion. Now, here we have some conditions to perform binary search tree deletion. You need to concentrate much more on this. Why? Because this is just not like insertion or deletion. Insertion or searching. Here we have few more conditions that has to be applied while deleting a node from the binary search tree. Okay. Deletion operation is performed to delete a particular element from the binary search tree, right? If I want to delete a particular node from the binary search tree, then we are going to perform this deletion operation. While it comes to the deleting a node from the binary search tree, the following three cases are possible. Here it will be follow three cases. What are the three cases that it will follow? First case, delete a node having no children. First thing is, a node with no children can be deleted. This can be done directly. You don't have any problem. Just to remove or disconnect the leaf node that is to be deleted from the tree. If you don't have any children for a particular node, that is nothing but the leaf node that can be deleted directly. If not the case, The other one is there. Other case is what? Delete a node having only one children. Right? We are going to delete a node with only one children. How we are going to delete it? And the last one, delete a node with two children. If I am having two children, how I am going to delete? As we have discussed, with no children, delete a node having no children is nothing but the leaf node. That can be removed directly. You don't have any problem. When we are going to do these two cases, in that we need to check for some more conditions to be followed when I am going to delete only one children or two children. Let us see the two cases. Here, the first case, no children, right? I am going to delete the value 20 from the BST, first case. This is 20 is a leaf node, right? Because of that, I can directly remove that one, right? I can delete that particular node directly, no problem. Now, delete a node having only one child. Only one child. Now, observe which of the node is having only one child. This is the one where you are going to have a node with one children. Now, just make the child of deleting node the children of its grandparent. Children of its grandparent. Okay. Now, consider the following example where we are going to delete 30. I want to delete the element 30. This has to be deleted. Now, what I need to do? I am going to remove this 30 from here and I am going to replace with this children. Okay. I am going to replace with the children either on the left, if I am going to have the left child or right child, that is going to be replaced with the deleted element. That means we are going to get 40 here. I think so you are getting it. Next, the other case, deleting a node having two children. Now, here we have two methods to follow to do this. Let us observe. A node with two children may be deleted from the BST in two ways. The method 1 and method 2, two are there. Visit the right subtree from the deleting node. First, completely visit the right subtree of the deleting node. Plug the least value element called in order successor. Replace the deleting element with its in order successor. Right? In order successor. With that, we are going to replace. Let us see what is happening here. This is the example where you need to delete the element 15. Why? Because in 15 is nothing but a node with the two children. It is having two children. Now, I can delete this 15 element and I can either go with the method 1 or method 2. In method 1, what we are going to do is, we are going to replace that with the in order successor. In order successor we are going to place. Just observe, from this we need to go for the right subtree. This is the right subtree. Right? This is the right subtree. Which is the in order successor here? If I am going to represent a in order, that is in order traversal, based on that, if I am going to represent the elements here, what are the elements I am going to get? 2, 10, 12, 15, 16, 17, 19, 20 and 30. Right? This is the in order traversal where if we have done. In this, if I am going to remove this 15, in order successor is nothing but 16. Successor means the next element. Predecessor means the previous element. In order successor is 16. This element has to be replaced with the element which I am going to delete. Okay? Which I am going to delete. That means I am going to delete this 16 and that is going to be replaced with the element of 15. This is one procedure. When I am going to select a right subtree. This is method 1. If I am going to select a left subtree, in that case, how we are going to replace that 15 with which element? Okay, let us see. The method 2, visit the left subtree. If I have selected the left subtree element, that is left subtree to be selected for replacing with 15. Plug the greatest value element called in order predecessor. I told you, right? In order successor and in order predecessor, both will be there. Okay. Here I have selected in the right subtree in order successor I have selected. But here I am going to select the in order predecessor. In order predecessor is nothing but 12. Right? That will be replaced with the element of in order predecessor. The same thing. If I am going to write the same elements in the order 2, 10, 12, 15, 16, 17, 19, 20 and 30. Okay. This is the in order traversal where you are going to get. If I am going to select the left subtree from this, I need to take the in order predecessor. Predecessor is nothing but 15 before. This is the one. This is the predecessor, right? This is the predecessor. Predecessor is nothing the previous element, right? This has to be replaced with the 15. That means I am going to delete this 15. That is going to be replaced here. Okay, like this way the method 2 is going to be applicable. In method 1, in order successor will be taken. In method 2, in order predecessor will be taken. Okay, these two cases. In order successor will be taken from the right subtree. From left subtree, we are going to take the in order predecessor. Right? These are the differences you are going to find when you are going to delete the element from the binary search tree. Let us see what is the summary for today's session. We have seen about binary search tree, what is the definition of binary search tree and what is the difference between binary tree and binary search tree also. Then binary search tree construction we have seen. If you have given some elements, how we are going to construct a binary search tree. And we have seen the insertion operation, then deletion operation, what are the methods to delete an element from a binary search tree. And we have come across the searching also, right? I hope you understand this concept. Thank you.